In this video lesson, I will introduce the concept of free fall. Free fall is when any object falls to the earth under the influence of only the acceleration due to gravity. So this topic is about objects falling to earth due to the acceleration of gravity. So one of the classic examples is the story of Isaac Newton being hit on the head by an apple. So imagine we have an apple, and I'm holding it, and then I drop it, and by dropping it, I just let it go, and it falls to the ground. The apple's in free fall because the only acceleration on it is due to gravity. What we know is that this acceleration has a specific value, and that specific value is negative 10 meters per second squared. Now I want to say a few things about that number. First of all, remember that acceleration is the change in speed that an object experiences in a given amount of time. So when I say 10 meters per second squared, what I'm really saying is the apple's speed increases by 10 meters per second for every second that it falls. Some other stuff. You'll notice there's a negative sign out front. That negative sign gives us direction. The negative sign means that the apple is gaining speed in a negative direction. In our case, the negative direction is down. So it is, as we said last unit, speeding up, moving down. The other thing I want to point out is that your textbook starts off by telling you that the acceleration due to gravity is actually negative 9.8 meters per second squared, but we will round that up to 10. Negative. Just to keep the math simpler. It's okay to use 9.8, it's okay to use 10, we can go back and forth. So this is a quick introduction to free fall. Now, in this slide, I want to actually explore what does it mean. Oops, let's change that. To fall to the earth with an acceleration of negative 10 meters per second squared. So as I said on the last screen, we know that it's going to gain 10 meters per second each second moving down. So going to go back to this concept of the apple falling. So here's my apple, and here's where it is at 0 seconds. I'm going to let it fall for a second, and it will be down here. And so the question is, how fast is it moving after that 1 second? Well, you'll recall I just said it gains 10 meters per second each second. So that means at 1 second, the apple would be moving with a velocity of 10 meters per second, and it's going down, so I'm going to put a negative sign in front. If I let it go for another second, after 2 seconds, it will be falling at 20 meters per second downward. So you see that I'm adding an additional 10 meters per second every second. Well, technically that's minus 10 meters per second in 1 second. It's minus because going from negative 10 to negative 20 is minus 20. So let's look at this apple over a much greater fall. So we have a little more space now. Here's 0 seconds. Here's 1 second. Here's 2 seconds. Here's 3 seconds. If I wanted to figure out how far it has fallen after 3 seconds, just remember that each second we are subtracting minus 10 meters per second. And then we subtract another minus 10 meters per second. And then we subtract it again, minus 10 meters per second. Or we'd be traveling at a velocity equal to negative 30 meters per second. So here's the pattern. To figure out the velocity that it's falling at, I'm going to call this v2 because it's the velocity at the end of some time interval. All I have to do is take the acceleration due to gravity, negative 10 meters per second squared, and multiply it by time. Your textbook writes this a little differently. It writes it as v2 equals g times t. If you hadn't figured it out by now, g is just a shorthand way of writing negative 10 meters per second squared. Okay, so you take a minute now, and I want you to figure out how fast will a baseball be traveling if it falls for 12 seconds. So I'm going to let you do that workout for a few minutes. You can pause, go ahead, figure it out, and then come back when you're ready. Okay, so the equation that you have is that v2 equals g times t, where we know g is negative 10 meters per second squared. So v2 is simply negative 10 meters per second times 12 seconds, where the ball is traveling at negative 120 meters per second, which is rather fast. A 12-second free fall might be off of something like the top of the Hancock Tower in Boston, or maybe like the Empire State Building in New York. It's very fast and a long fall. What if I asked you now, how fast would the baseball be traveling if it fell for 3.2 seconds? So you go ahead and figure that out, pause, and then come back when you're ready. I'm going to do the same thing I did before. But this time, our time is just not a whole number. So I'm going to multiply by 3.2 seconds. And I see that the velocity is negative 32 meters per second. This concludes the end of video number 1.